So in the U.S., this is common. Unfortunately, it's not just the frogs getting moved around in this way, but the diseases that they carry also. So like the rhinovirus has been moved around, at least in North America, via the hatchery and the bait industry. So, anyway, you have 3 invasive species so far from Australia, and I don't know if there are other species taking root as well, getting established.
What is it about climate change that creates that virus you mentioned, or the fungus?
Well, it doesn't create it. So this chytrid fungus seems to have always been around, because what we can do is really interesting. One good reason to have museum collections long term is that in this case we can actually go back and look at old specimens collected 100 years ago and look at their skin and find the little nodules created by the fungus. And so we know, based on that, looking carefully at these old formalin preserved specimens, that chytrid has been around for a long time. But what we think has happened with some recent changes and recent climate changes is particularly in areas, in sort of high altitude areas where the change is more dramatic, the temperature shifts are more dramatic. It's in those bands of habitat at high altitude areas where the chytrid is suddenly able to survive in areas that it couldn't before because the temperatures were prohibitive for its growth. And so now we have a whole suite of species being exposed to the chytrid for the first time, and they haven't evolved any resistance. So yeah, that's where the problem areas are. So like I showed you that cylindrical shaped graph where the highest species diversity of frogs in Ecuador is in the Andes, so up in those high altitude areas. Those are the hard hit areas from the fungus where the most species are going extinct, unfortunately.
Any estimate on how badly frogs are being hit? For example, with insects, 75% reduction in 27 years is a European study recently. How much are frogs going down in terms of disappearance?
Yeah, I haven't looked at those stats lately, but I think it's somewhere around like half of the known species of frogs are at risk at this point. But don't quote me on that. It's a high proportion of the species, though.
Does the EPA in the States collect frog specimens from around the States to store in their specimen banks?
I don't know the details of what exactly the EPA is doing. I'm more involved on the academic side of things, so I'm more in touch with like museum curators at the American Museum and the Smithsonian and other big institutions in the U.S. And yes, they're continually making collections of all different species, but especially the ones that are declining, and trying to document them and preserve tissue samples before it's too late. But I also have colleagues who are working on trying to capture the last remaining individuals of species that are almost extinct and bring them into captivity and keep them in what are called amphibian arks. And different zoos around the U.S. Have these amphibian arks where they may specialize in a handful of species that are now extinct in the wild, but they're breeding them in captivity with the hopes that someday we'll be able to reintroduce them in the wild. Especially if sometime in the next few years we can introduce a chytrid-resistant gene into these lines and keep them going. I don't know. That might be a long shot, but it might be the only hope for reintroducing animals to the wild someday.
Just go on your point, you mentioned about fish breeding spreads the Aussie frogs. Maybe we shouldn't be dumping non-native fish into waterways and lakes.
Yes, I completely agree with that idea. I don't know what the economic consequences of that would be, but in terms of all the revenue that the country gets from fishing, but I am all for that plan.
Yeah, but it sort of counteracts their sort of so-called green environmental push that they try to play themselves as an environmental friendly organization.
Right, yeah, I think that needs to be thought through a lot more carefully, that sort of approach. Yeah.
There's also mercury problems coming up with lots of mercury, dumping non-native fish into the area and adds mercury to the
to the ecosystem in general. Yeah. Other questions? Mhm.
Do you have a timeline for the divergence of the species that you were working on? So, like, has that been recent, or has that been since, like, the Ice Age or something like that?
Right, so that is an excellent question. I would like to know myself. We do have the call data that Jack Fouquet collected in the 1950s and 60s in a lot of these areas, and the frogs had already diverged in these contact zones about 50 years ago when he collected the data. So the divergence is at least that old. In terms of how rapidly it happened, that's really difficult to say. One of my dreams someday when I have lots of extra money and time is to do an artificial sympatry experiment where I take frogs from allopatry and put them together in a giant enclosure with a natural pond outside and just watch evolution happen. Let them interact, try to hybridize, selection against hybridization to drive them apart, and every year measure their phenotypes and watch what happens. Now, ideally, you would replicate that experiment, so you'd have 20 or 40 of these giant enclosures and breeding populations. And at this point, our funding rate in the United States is not that great, so I really doubt I'd be able to get money to do a replicated experiment, but it would be fun to do at least one replicate. But in terms of reconstructing how fast that happens, we don't know for sure. In Drosophila, so in fruit flies, people have done these experiments, and because in fruit flies it's great, you can do this whole experiment in a tube and replicate it really easily. And they found it only takes a few generations. I think it was on the order of fewer than 20, somewhere between like 10 and 20 generations for substantial behavioral isolation to evolve between species.
Because I would have thought they would have already done that by now.
Done what by now?
Their divergence. So obviously something's caused them to come together again.
Okay, so you're asking about the divergence across the different populations of the same species. How fast did that happen? Yeah, again, I don't know. I don't know at this point how quickly that can happen. We do know that much of the range, the coastal plain range of Brimley and Nigrita was underwater relatively recently. That was all ocean not that long ago. And so those species have recently moved into those areas, and contact zones thus have recently formed in the last, maybe 10,000 years or so. But I would suspect that the divergence we've seen has evolved in much more rapidly than 10,000 years. So I don't think it takes that many generations.
Thank you.
All right, well, thank you all for your questions and interest, and if you want to chat any more afterward, I'm happy to. Thank you.